We're taking a look at one-directional limits now. And when you consider one-directional limits, you're looking at what we also call, they're also called one-sided limits. So what we mean by that is that you have a special notation. The notation looks like this. All right, this is in general. So this is a limit in general. This indicates, that little minus sign indicates that we're looking at the limit from the left, or a left-hand limit. And this right here off to the side, okay, oops, bring that back real quick. This right here indicates that we're looking at it from the right-hand side. Okay, so what happens is that a limit in general exists if and only if these two limits, the left and the right, are equal. They must be equal. So what I tell my students is the left-hand side has to equal the right-hand side. So when you're looking at a limit in general, you have to make sure that the left and the right are the same. All right, so let's take a look at some examples, and then we'll try to make some sense of this. So let's take a look at the first. It says we were given some function f of x that's graphed here on number 1, and they want us to look at -1. Okay, so I'm going to take a look at -1. And where is -1? -1 is right here. So let me go ahead and follow this. As I'm coming towards -1 from the left, my left-hand side is approaching this number -2. So the left-hand limit here would be -2. Okay. Now, as I'm coming towards -1 from the right, okay, I'm approaching this number right here, which is -7. So that's what we're getting close to, -7. Okay, so that's my answer there. Now, it's not asked about the limit in general, but we can answer that question here. The limit in general does not exist because the left-hand side does not equal the right-hand side. Now, another thing to note is that right here at this point, you see this open circle. Well, that open circle means it's not defined. It is actually only defined right here. All right, it kind of jumps, if you will, a step function, a jump function. Okay, it's discontinuous, but that does not mean that the left-hand side limit or the right-hand side limit do not exist. However, the limit in general does not exist because if you look at it here, we are approaching two different values as we approach from the left and from the right. Okay, so hopefully that makes it clear about one-sided limits. Let's take a look at one more example here. This one, a trig function. We're asked in this case to find the left-hand limit as x approaches pi over 2, and then the right-hand limit as x approaches pi over 2. So again, where's pi over 2? It's right here. It's right here. Okay, so we're going to draw our dotted lines here. The left-hand limit is this direction. As we approach pi over 2, it looks like we're approaching the number 4. So pi over 2 from the left, it equals 4. That's my first limit there. Now I'm going to look at pi over 2 from the right. So as I come in from the right on x, my y value is approaching this number right here, which is 3. So this one right here is 3. So what we can say about the limit in general, and I'll write that, I have some space here, the limit as x approaches pi over 2 in general of f of x, we would say does not exist. Right? It's not being asked here, but you might say that, okay? Because the left-hand side, and here's our justification, the left-hand side does not equal the right-hand side, okay? So just a small bit on one-sided limits, graphically anyways. So as always, if this video was helpful, be sure to like and subscribe.